So welcome to this latest video on 162 Maths, and in this video we'll be going over some past GCSE exam questions related to compound units. Now as always there'll be a copy of the test paper that we go through in this video as a link in the description, and I'll also include some lesson links that go over this topic in greater detail. Now before we get started working through some past exam questions related to compound units, let's just have a quick overview over what it is you need to revise and know. Now compound measures is when you have a combination of units. Now compound measures are often used for such things as force, speed, density and pressure, which are all calculated using a formula that uses a combination of different variables, i.e. length, weight, mass, volume, area, etc. Now to convert compound units you need to write numbers as fractions, convert the units for the numerator and the denominator separately before finding its value. Now be sure to always read the question carefully and take note of not only the units for the answer but also the units for the variables as well, because obviously sometimes these can be a mixture and you may need to do some converting beforehand. And also most formulas will be given, but you should be familiar with them. Now in terms of the formulas that you need to learn for compound units, these are probably the four of the most popular ones. Now the ones with little asterisks are the ones that you need to know off by heart, whereas with force and pressure you will tend to be given those in the question itself. Now one way to learn the units for speed, pressure and density is to actually look at the units. So here if we look at speed, so the units for speed is going to be a distance unit rather, per or slash a time unit. So for example you could have miles per hour, you could have meters per second, but looking at the units that should give you an indication about what the formula is. So here this is going to be distance, so the first unit is a distant unit or length unit, and the second unit is a time unit. And as you can see the formulas are exactly the same. The same thing for pressure, so units for pressure is going to be a force unit per an area unit. So for example you could have newtons per centimeter square. So again this is a force unit, this is an area unit, and then divide, and lo and behold just by looking at the units you've got the formula. And the same thing applies for density. So here the units for density is going to be a mass unit or weight unit per volume unit. So you could have kilograms per centimeter cubed, in which that's mass, that's volume, divide, and you've got the formula. So again, a nice little way of letting the exam paper give you the information that you need. So now let's get started working through some past exam questions. Now again, a reminder, if you want access to this question paper, all you need to do is just simply click on the link in the description. Alternately, pause the video as I read the question, have a go at it, unpause as you go through the answer. So looking at question 1, it says the solid has a volume of 400 cubic centimeters and a density of 6.1 per gram per cubic centimeter. What is the mass of the solid? And it's only worth 1 mark, so we just need to look at the formula. So for this, the formula for density is mass over volume. So what I just need to check is the units are the same. So here the volume is in centimeter cube, and the density, the volume, is also in centimeter cube, so that's absolutely fine. So I just need to rearrange the formula for density for mass. So mass equals density times volume. So the mass is going to be 400 multiplied by 6.1, which gives me an answer of 2440. Then for question 2, it says Mason drives 305 miles in 5 hours. He drives the first 50 miles at an average speed of 40 miles per hour. Work out the average speed for the rest of his journey. So first things first, let's just look at the formula. So here we've got that speed equals distance over time. So I want to work out first of all the time it's taken for his first part of the journey. So if I just write time for the first part, now time is equal to distance divided by speed. So for this I need to do 50 divided by 40 which gives me an answer of 1.25, and that's going to be in hours. So that's 1 hour and 15 minutes. Then if I take that away, so the distance for the second part is going to be 305 minus 50, because he's already travelled 50 miles for the first part, and that's going to give me 255, and that's in miles. So then to work out the average speed for the second part, it's going to be, or speed is equal to distance divided by time. So the distance is travelled is 255 divided by the time. So if I then do, the total trip took 5 hours. So for the time, it's going to be 5 hours minus 1 hour and 15 minutes, which gives me a time of 3 hours and 45 minutes, or as a decimal, 3.75. So otherwise, I think what would have been better is if I did 5 minus 1.25, I get an answer of 3.75. So the time in hours is 3.75. And what's good practice is just writing down the units as well. So then working out the speed, 255 divided by 3.75 gives me an answer of 68 miles per hour. Legal Alex, zoom on that one. Moving on to question 3, it says Betty is paid £10.50 an hour for working 36 hours a week. When she works more hours in the week, she gets paid £13.65 an hour. How much does she earn in a week where she works 42 hours? So this is basically saying that her basic pay is £10.50, her overtime pay is £13.65. So looking at this, for 42 hours, 36 hours are paid at basic rates. So that's going to be multiplied by £10.50. And then 42 minus 36 is 6. So it should be paid 6 hours at the overtime rate. So if I work out each of those amounts, so that's going to be £378. And this is going to be £81.90. So then if I just add those two amounts up, I get a total pay for Betty of £459.90. Moving on to question 4, it says a gold coin has a density of 19.3 grams per cubic centimetre and weighs 12.4 grams. A silver coin has the same volume, has the density of 10.49 grams per cubic centimetre. What is the mass of the silver coin? So again, density is equal to mass over volume. Now, what I need to do for this particular question is I need to work out the volume of the gold coin. So to do that, I need to make V the subject. So V equals mass divided by density. So that's going to be equal to, now just double check to make sure the units are correct. So grams in the density units and the weight is in grams. So that's absolutely fine. So it's going to be 12.4 divided by 19.3. And that gives me an answer of 124 over 193 as a fraction. But as a decimal, it's 0.642 blah blah blah. So then what I then need to do is then the volume is the same, so the volume of the silver coin is the same, so that equals 0.642, which is still on the calculator. So then to work out the mass, well, mass equals density times volume, so it's going to be 0.642 multiplied by 10.49, and if I type all of that into my calculator, I'm going to get an answer of 6.74, and that's to 2 decimal places. Moving on to question 5, it says Michael and Lee are 2 runners in a 400 meter race. Michael completes the race in 75 seconds. Lee completes the race at an average speed of 18 kilometers per hour. Who wins the race? So for this, what we need to do is we need to convert Michael's, well, one way of working this out is to convert Michael's units to work out his speed in kilometers per hour. Now we need to make sure that the units are the same so it's easy for us to compare. So again, looking at Michael's, if I can spell his name right, which I've got the A and the wrong way around, so there we go. So remember, speed equals distance divided by time. So looking at the units, we know it's 400 meters over 75 seconds. Now what we need to do is we need to convert that into kilometers, and we need to convert the time into hours. So meters into kilometers, well, that's going to be relatively easy. So here I divide by 1000. So 400 divided by 1000 gives me an answer of 0.4. Now to convert seconds into minutes, I need to divide by 60 to convert it into minutes, and then to convert it into hours, I need to divide by another 60. So altogether, I'm going to divide by 3,600. So if I then do 75 divided by 3,600, I get an answer of 1/48, which as a decimal, let me just write that down, but I'm going to keep it as a fraction because I want to be as accurate as possible. Works out to be 0.02083 recurring. So again, you've got a choice between either writing the decimal or writing the fraction. It's entirely up to you which one you want to go for. I'll probably go for the fractions. I'm going to do 0.4 divided by 1/48, in which if I type that into my calculator, I get an answer of 19.2 kilometers per hour. So all that's left for me to do is compare the two speeds. So Lee was traveling at 18 kilometers per hour, Michael at 19.2 kilometers per hour. So obviously if you're traveling faster, you're going to get there, you're going to finish quicker. So the answer then is Michael. Moving on to question 6, it says two solids A and B have the same density but different volumes and masses. Complete the table, include the units in your answer. So for this, again, looking at the formula, density equals mass over volume. So to work out this number here, I'm going to do 144 divided by 9. Now remember, the units are grams per centimetre cubed. So if I do 144 divided by 9, I get an answer of 16. So it's going to be grams per centimetre cube. And again, those units come from doing mass divided by the volume. Now it tells me in the question that they have the same density. So this is also going to be 16 grams per centimetre cubed. So then working out volume, rearranging the formula, that's going to be mass over density. So here I'm going to do volume equals 192 divided by 16, and that gives me an answer of 12, and the units for that are going to be centimetre cubed. Moving on to question 7, it says a car travels 3.8 miles in 4 minutes. Work out the average speed in miles per hour. So looking at this, we're going to write 3.8 miles over 4 minutes. Now we want miles, so I want miles, but I want hours as a denominator unit. So miles, that just goes straight in, so that's just 3.8. Now converting minutes into hours, what I need to do here is I need to divide that by 60. So 4 divided by 60 is 1/15, so I'm going to leave it as a fraction, so 1/15. So to get the answer, I need to do 3.8 divided by 1/15. And if I type that into my calculator, I'm going to get an answer of 57 miles per hour. Moving on to now, one thing you should note when working with speed and maths papers is if you know anything about speed limits, it's highly unlikely that a car will ever be breaking the speed limit, because obviously that then causes a lot of issues with legalities. However, if it's a plane or a train, then it's going to go more, it could go more than in excess of the national speed limit. So just be mindful of that. You're not going to have a car or someone running at, let's say, 120 miles per hour. It's just not going to happen. Moving on to question 8, it says that a solid piece of copper has a mass of 2.136 kilograms and a volume of 240 cubic centimeters. It says work out the density of the copper, give your answer in grams per cubic centimeters. So again, looking at the volume, its density equals mass over volume. So looking at this, if we read what we've got, so the mass is 2.136 kilograms over 240 cubic centimeters. Now looking at the answer, I want the answer in grams and I want it in cubic centimeters. Now the cubic centimeter denominator is exactly the same, so I can just write that underneath. However, I need to convert the grams into kilograms into grams. So here I multiply by 1000. So that's going to be 2136 divided by 240. So 2136 divided by 240. And that's going to give me an answer of 8.9. And again, units already written for me, so I don't need to worry about writing it. Then moving on to question 9, it says that a car tyre exerts a force of 4,800 newtons on an area of 0.2 square meters. Work out the pressure the tyre exerts on the ground. Give the units for your answer. So using this formula, we get P equals, now the force is 4,800 newtons over the area, which is 0.2 meter square. So then doing 4,800 divided by 0.2 gives me an answer of 24,000. Now the units are going to be newtons over square meters. So I'm not messing around with the units, I'm just going to keep it as is, which is why it's only worth 2 marks. Then moving on to our last question, it says the distance by road from Manchester to Glasgow is 225 miles. The distance by road from Glasgow to Inverness is 170 miles. Peter travels by coach from Manchester to Glasgow at an average speed of 60 miles per hour. He has 1 hour and 15-minute break in Glasgow. He then travels to Inverness at an average speed of 40 miles per hour. He leaves Manchester at 8:30 a.m. What time does he arrive in Inverness? And it's worth 5 marks. So for this particular question, we're going to be using distance equals, or speed actually. So I'm going to pause there. So speed equals distance over time. Now if you want to use the triangle, though it's kind of becoming a bit frowned upon now, we can use the triangle because I'm going to be working out a mixture of distances and times. So looking at this particular question, the first thing we need to do is if we look at the Manchester to Glasgow. Now the information I know is I know the distance and I know the speed. So what I need to do is I need to work out the time. So for this, time is equal to distance divided by speed. So the distance is 225 miles. Now the units for the speed are miles per hour. So any time units is going to be in hours and any distance is going to be in miles. So it's just something to be wary of. And I divide that by 60. So that gives me an answer of 3.75 hours. Now that converted is going to equal, well, I'm going to leave it as a decimal, but if I wanted to convert it into times, that's 3 hours and 45 minutes. So then what then happens is he then takes a break, and the break is for 1 hour 15 minutes. Now 1 hour 15 minutes in hours only is 1.25 hours. So then I need to work out how long it takes to get from Inverness to Glasgow. So Glasgow to Inverness, and again the time is the distance, which is 170, over the time, the speed, which was 40 miles per hour. So 170 divided by 40 gives me an answer of 4.25 hours. Now that in hours and minutes is going to be 4 hours and 15 minutes. Now for the break, 1.25 hours is 1 hour, and that's 1 1/4, so it's 1 hour 15 minutes. So all I then need to do is then add these times together. So 3 hours 45 plus 1 hour 15, it's going to be 5 hours. So in total, it's 9 hours and 15 minutes. So if he starts off at 8:30 a.m, I then need to add 9 hours and 15 minutes. So 8:30 plus 9 hours 15 minutes takes me up to 17:45 as a 24-hour clock, or 5:45 p.m. using a 12-hour clock. And that concludes the end of this topic test.